This is solving inequalities using multiplication or division. We're going to start by looking at problems that are solved using multiplication. The multiplication property of inequality states that when you multiply each side of your inequality by the same positive number, the inequality remains true. Let's see how this works by doing a few example problems. We're going to solve them and graph them. So in our first problem, we have x divided by 5 is less than or equal to 2. We're always looking for our variable, which in this case is x. That's where we're going to start, and we need to get x by itself. We're solving for x. So right now it says x divided by 5. To get rid of the divided by 5, I'm going to use my inverse operation. So I'm going to do the opposite, which is multiply by 5. If I multiply this side by 5, though, I also have to multiply the other side by 5 to keep it fair and balanced and to make sure that my inequality remains true. So in this case, the 5s will cancel out, and on this side, 2 times 5 is 10. The last thing I'm going to do to solve this inequality is I'm just going to take my inequality sign right here, not changing it or anything, I'm just copying it down here between my variable and my final answer. So x is less than or equal to 10. When I go to graph it, I want to make sure 10 is on my number line. But I'll do a few numbers greater than 10 and a few numbers smaller than 10. But 10 is where my circle is going to go. That's the most important number. In this case, at 10, I'm going to fill in my circle because I see that x can be equal to 10. So I want a filled in circle. I'm shading in 10. It is a potential answer. My other answers for x can be anything less than 10. Because it says x is less than or equal to 10. So my numbers that are less than 10 are always to the left, like 9 and 8. So I'm going to shade to the left. Everything going this direction is a potential answer. And my numbers keep going, so I'll even shade the area. Let's look at a second example. Here we have p divided by 3 is greater than 2. So p is the variable, this is who I'm solving for, but I need to get rid of this divide by 3. So I will multiply each side by 3, do my inverse operation, this will cancel out, and I'm left with p, and over here I have 6. And my final step in solving is to bring that inequality sign down. Don't change it at all, just copy it down here between your variable and your answer. So p is greater than 6. So on my graph, I'm going to put 6, and a few numbers on each side of 6, a few smaller, a few greater. At 6, I'm going to put my circle. This time it's going to be an open circle because I don't have an equal sign. P can't be equal to 6. 6 is not really an answer, so I'm keeping it open. P, it says, is greater than 6, so that's like 7 and 8, everything to the right, so I'm going to shade this direction this time. All right, last one here. 3/4 times q is greater than or equal to 6. So you might be thinking, well, q is my variable, but I'm multiplying by 3/4. And isn't the opposite of multiplying dividing by 3/4? And this is supposed to be problems that I solve using multiplication. Well, if I'm going to divide each side here by a fraction, my shortcut when dividing fractions is to multiply by the reciprocal. So when I'm trying to get rid of a fraction that's being multiplied by a variable, the way that I do that is I'm going to multiply each side by the reciprocal of the fraction. In this case, the reciprocal of 3/4 is 4/3. Now 3/4 and 4/3 will cancel out, and I'll be left with q. On this side, I'm going to add a 1 under my 6 so that I have 2 fractions to multiply. I also see some cross-reducing that I can do before I start multiplying. 3 divided by 3 is 1, and 6 divided by 3 is 2. On the top here, 2 times 4 is 8. On the bottom, 1 times 1 is 1. 8 over 1 is just 8. And then I copy down my inequality sign. So in this case, q is being compared to 8. At 8, I'm going to put a closed circle because q can be equal to 8. I see the equal sign. It also says q can be anything greater than 8. So that would be like 9 or 10. So I'm going to shade everything here to the right, everything greater than 8. Now let's look at some problems that can be solved using division. The division property of inequality says that when you divide each side of an inequality by the same positive number, the inequality remains true. So in our first example, we have 4 times n is greater than 32. So n is our variable, and right now it's being multiplied by 4. I want to get rid of that 4, so I'm going to use my inverse operations. I'm going to divide each side by 4. So here my 4's cancel out, and I'm left with n. 32 divided by 4 is 8, and then I bring down my inequality sign. So n is greater than 8. So I'm going to put 8 on my number line, and at 8 I'm going to have an open circle this time. Does not say n could be equal to 8. It says n is greater than 8. So things that are greater than 8 are to the right, like 9 and 10. So I'm going to shade this direction. Here I have 5 times j is less than or equal to 20. J is the variable, but right now I have times 5. To get rid of it, I'm going to divide each side by 5. So I have j here, 4 here. I bring down my inequality sign. This time, at 4, my circle is going to be a closed circle because j, it says, can be equal to 4. It is a possible answer. J is also anything less than 4. So I'm going to shade to the left. 3 or 2 or anything less than 4 could also be an answer here for J. Finally, let's look at a real life example. So if I buy a one-way bus ride ticket, it costs $1.75, but if I buy the 30-day pass, it costs $42. So they want us to write and solve an inequality to find the least number of one-way rides you must take for the 30-day pass to be a better deal. Okay? So if I just take a one-way bus ride, it's $1.75 every single time. So it's $1.75 times however many times I ride. So I'm going to use R. If I do the 30-day pass, it's just $42. But I want this to be a better deal. I want this to be less than paying individually every time. So I want to know, when is this money exceed $42? When is this bigger than 42? So to solve, I'll divide each side by $1.75. And 42 divided by $1.75, I get 24. So I have to take 24 of the one-way bus rides. I have to ride more than 24 times, more than 24, for it to be a better deal to buy the 30-day pass. Well, it says you ride the bus an average of 20 times each month. So is the pass a better deal? Well, a month is roughly 30 days, so I can imagine that if I buy the 30-day pass, it's basically a month-long pass. But if I only ride 20 times, it's not going to be a better deal. I have to ride more than 24 times for the 30-day pass to be a better deal. So no, I don't ride enough for the 30-day pass to be a better deal. Now, if I had ridden every month more than 24 times, I would have answered this differently. But if I only ride about 20 times, it's better to just pay every single time I ride the bus.